Oh, sir, the answer for x equals 5, that was correct, 7.5.
It was 7 point.
7.5, that was correct.
7.5. Okay. Then when you sum them up, summation.
The 12.
12.78.
79. 79.
79. Okay, so she's saying 12.79. Is this seconded? Can we get that value as a gospel truth? Okay, so remember the variance. So this figure we've gotten the 12. This is expected of x squared. So this figure we've gotten, this one is expected of x squared. So now to find the variance, remember the formula for variance. So we want the variance of x. To compute the variance of x, we said the formula is expected value of x squared minus, in brackets, expected value of x, then you square the whole entire thing like that. So expected of x squared minus that. Then we'll get the given figure. So expected of x squared is 12.79 minus the expected value of x is this guy, which is 3.27. So 3.27. That is the expected value of that. Then you square it. So the variance in our case is 12.79 minus, so those with calculators, 3.27 squared. What do you get? 3.27 squared. Where is that our assistant student with a calculator?
2.0971.
When you square
3.0971.
3.27 squared, what are you getting?
And I square 3.27. That
Sir, the
gives
correct
me
10.69.
10 point
10.69.
10.69. Then
10.69.
when you subtract, what are you getting?
2.09.
2.1.
Not 2.10.
Yes, 2.1. 2.10.
Yes, so the variance of x is 2.10. That's the variance of x. So we've computed the variance of x and we've computed the expected value of x. So that's how you compute the variance of x and the expected value of x from the given information. Now we can answer the questions that are given. Remember, the next question is question 3, which is saying compute expected value of 2x, expected value of 5x plus 6, and expected value of 8. So these are the things we're supposed to compute. So we'll start with expected value of 2x. So what's the expected value of 2x? So let's add one more blank space. Okay, we'll need it just above this one. So we'll need a blank page. So let's add a blank page so that we can have, yes, so there we go. So what we want is the expected value of question 3 is saying compute expected value of 2x. So we'll start with 2x. So what we what we do in such a case is just simply so expected value of 2x it's bookie. Say this Word document was performing. Now we'll get back. So what we want is expected value of 2x. So like I said, you apply the property. This is 2, you bring it out, so it will be 2 times expected value of x. Then you replace, of course, you substitute 2 times. What was the computed expected value of x? What's the expected value of x? So you substitute this 2 times 3.27. So expected value of x is 3.27. And what do you get? 2 times 3.27, what do you get?
6.54.
6.5.
5.
So it means that the expected value of 2x is 6.54. Any questions? Okay, so if there are no questions, we proceed and answer the previous or the next question. Expected value of 5x plus 6. Expected value of 5x plus 6. So the next question, they want us to compute expected value of 5x plus 6. So we are going to apply the linear property by splitting this and that. So we are going to have expected value of 5x like that plus expected value of 6 like that. So we split expected value of 5x plus expected value of 6. Then we continue. Now remember, this 5 is attached to x, so you can bring it out. So have 5 times expected value of x like that. Then plus expected value of 6 like that. Then from there, we have 5 times what is the expected value of x from the computed figure? It's 3.27. So you just substitute that plus. Then we said expected value of a constant. There is no variable there. So expected value of 6 is just simply 6 itself. So expected value of a constant gives you the constant itself. So expected value of 6 is simply 6. Then you can, those with calculators can compute that for us. 5 times 3.27 plus 6. What do we get as our final answer, please?
22.35.
Sorry?
22.35.
23.35, like that?
22, sir. 22.35.
My friend, you're saying 23 or 22?
I'm saying 22.
22, okay. Okay, so 22.35. So 22.35. So that is the expected value of 5x plus 6. That's how you compute the expected value of 5x plus 6. Then we can proceed and answer the expected value of 8. Anyone to give us the answer for expected value of 8? What's the answer for the expected value of 8?
8.
It's 8.
8.
So the expected value of a constant is a constant itself, which is 8. So we've answered the given question 3. We can proceed to question 4. What was question 4 asking us to find? So question 4 asks us to compute the variance of 2x plus 5. So variance of 2x plus 5. So we are required to compute number 4, variance of 2x plus 5, like that. So we apply the linear property. We say this is equals to, so we'll get the variance of 2x plus the variance of 5. So we have the variance of 2x plus the variance of 5. Then you proceed. These two will bring it out of the variance. These two will bring it out of the variance. So when we bring it out, it will be 2 to the power 2. So it will be 2 squared times variance of x. 2 squared, so when it comes out of the variance, it is a squared plus the variance of a constant. So this is variance of 5 is 0. Variance of a constant, if that constant does not contain x, then it's simply 0. Then it means that what we have for what we are looking for is 2 squared, which will give us 4 times variance of x. So 4 times variance of x. So we have 4 times, what was the computed variance? What did we get as our variance?
2.10.
2.10. So it just simply means 4 times 2.10.
Yes.
And that will give us
8.4.
8.40. So the answer for this guy is just simply 8.40. Are the students happy with the given information? Are we happy? Oh, okay. So silence means people are happy or people are not getting anything. So I'll take the positive part that the students are happy. Then the second part of this question is where they want you to find the variance of, what do they want? The variance of x minus 3x. The variance of x minus 3x. This is what they want. So we are applying the property, the linear property. So we are saying this can be written as variance of x minus variance of 3x, like that. Then variance of x, we know that that is 2.10. Then minus, remember this is 3x. So when the 3 is brought out, it will be 3 squared, which will be 9 times variance of x. So the 3, when it comes out from the brackets, when it goes out, it's squared. Remember, it's 3 squared. And that will be 2.10 minus 9 times 2.10. Then you can have your figure as 2.10 minus, those with calculators, 9 times 2.10, what are you getting? I assume that should be 18.90. I think 9 times 2.10, that should give you 18.90. Then people can compute 2.10 minus 18.90. What are we getting? Negative?
Negative 16.8.
Negative 16.80. So that is what was expected of you guys to do. Any questions?
Sir, could you repeat on the first two questions? I was late. I don't know how to find the expected value. Then I came in when you are solving for variance of x. So I didn't get the upper part.
The young man didn't get the upper part, and the young man want me to explain again how to compute. You are saying the expected value of the variance?
The expected value is the 3.2227. The variance I think I got now the table and the expected value of x. I don't know if it's the table, just a table thing.
Just this table.
Yeah, just from the first part. I came in when you're doing the variance of x.
Oh, okay. So that means
Yes.
please watch the recording. It will be shared so that we it may mean that I may just start the whole lesson, but to avoid complications, let's just watch the recording. Then when you have questions, you can be able to definitely get in touch with me so that
Okay, sir.
all right.
Okay.
So you can go through when you have questions. Then yeah, we'll do that.
If it's done, it's okay.
Okay, so I think there was a young girl that was following me. As you can see, let me share the question paper she was saying. So young lady, you can now solve this question. Now you have the information that you needed for you to attempt this question. So you can all try to attempt this question. It's coming from the previous card from, yeah, that's it, not much information. Then the other thing that I'm seeing is part C. The one that we are looking at is discrete. Remember, we talked about discrete and continuous. So now, if you look at the second question here, or the part C question here, it's saying let x be a continuous random variable. The following density function is given by this. So on this one, I'll explain a bit on how to go about it. Of course, it's similar to what we are just from doing, but in the sense that this is continuous. So for continuous, the properties are just the same, but for continuous, for it is continuous, we can use the integration to find the expected value, the integration to find the variance, then everything will just be the same. So let me now explain. Let me explain a bit. Let me explain on how to go about that, but you figure it out on your own. You guys are geniuses. Okay, so let me just explain a bit on continuous, but that means we've covered it. When I explain, it means we've covered it. So for continuous, probability, we'll say let f of x be a probability density function. Probability density function in abbreviated, which is abbreviated as PDF. Let f of x. So f of x will be the function. So if that is the probability density function, f of x, so it will be any function. So to find the expected value in a continuous random variable, the formula is integration of x times f of x dx. So when you integrate from the given interval from a to b, then that will be your expected value in a continuous random variable. So that is how you find the expected value in a continuous case. Then the variance is similarly the same thing that you know. What we just define in this case is, so for the variance is integration of x squared f of x minus, of course, dx. It's the same thing, minus integration of x f of x. Of course, we know this is expected value, then you square that. So this is just similarly the same thing. So if you look at this one, x is squared, of course, with a limit from a to b. So we take it as a discrete function from a to b. This is how you do it. So these two formulas are the formulas for computing the expected value and the variance in a given continuous interval. So I'll use that example from the young lady's past paper to teach how to go about that guy. So when you're given, for example, this one where you're given, let x be a random variable. So they give you the function. So they've given you the function to say, this only deals with x is greater than 0. Elsewhere, it will be 0. That's the function. So when we have x which is less than 0, because this is only qualified for x, the k e to the power, so we are saying we have two functions. If x is greater than 0, we know when x is greater than 0, then the function to use our PDF is k e to the power negative x. That's the function to work with. If x is greater than 0, we know numbers that are greater than or equal to 0. So it's 0, 1, 2, 3, 4, 5. Then the function work is this one. But if we have x less than 0, of course we know x less than 0, these are negative numbers, then the answer is definitely just 0. That's the meaning of 0 otherwise. So this function k e to the power negative x is only valid for x greater than 0. For x greater than 0. Then they are asking you to say, where k is a positive constant, find the value of k. Find the value of k. So we need to find the value of k. So let's get to let's get to our board where we do wonders. So let's have this. Okay. Are you guys already tired? Or you don't have power?
Yes.
Do we have information overload? Not really. People are enjoying and you want to distract us. So,
Say we want to sleep.
students don't sleep. Student is like a security guard. You have no life.
Say, these are things of the earth.
You don't sleep. Just buy juice so that you drink the whole night as you are studying. Okay, so we are saying the function of x is k e to the power negative x. This is for x is greater than or equal to 0. Then they want us to find that. So when they give you to say x is greater or equal to 0, if you are asked to find, remember for a discrete, we were saying summation of all the probabilities is equals to 0. So this is for discrete. Now for continuous, it's the integral from a to b of the function. Oh, sorry, this is equals to 1. Sorry, all the probabilities sum up to 1. So similarly, if you integrate the probability density function, the summation of this is equals to 1. Similarly, equal property applies in a continuous. So what that means is that for us to find the value of k, we need to integrate this and equate it to 1. So what we'll just simply do is get this function, and we've been told that this function values for x is greater than 0. So it means the lower limit, it's starting from 0 up to infinity. So what that simply means is, if you get the lower limit 0, because we are saying x is greater than 0, up to infinity, because they have not given us where it's ending, then you get your function k e to the power negative x, and say when you integrate this guy, you should equate it to 1, so that you can find the value of k. Then what you do is integration of this. So in case you missed it last year when you were learning, the integration of the k, when you're integrating, k is a constant, you can bring it out. So you bring your k outside the integral, then you have from 0 to infinity. So it means you just need to integrate this guy with respect to that, then equate to 1. So this is an exponent. So these are basics. E to the power negative x, when you integrate that, you get the same thing, but since the power is negative, so it will be integration of that guy will turn out to be the same e to the power negative x with just a negative. Then the limits we have from 0 to infinity like that, and this should be equal to 1 like that. Then we can substitute with the limits. Okay, so this should have been definite integral, which we did in your first year. So now the upper limit is infinity. So where there is x, when we put infinity, it means that we are going to have a bigger negative and it will give us 0. So when we insert in negative, we get 0. So it means we are going to have k, of course k, then this will be 0. Any number raised to the power 0, that will be 1. So it will be 1 minus, so 1 minus, then we insert 0. Oh, sorry, it will be 0. 0 minus, when we put 0 there, it will be 0. Any number raised to the power, that will be 1. Then this will be equal to 1. Then k, negative k, is equals to 1. Then we can find the value of k. K is just simply equal to negative 1. So k is negative 1. So the value of k is -1. Any questions? Or I've confused you? I need to come and explain this in class.
Yes, sir. Play in class. We're confused.
Yes, yes.
Yes. I'm lost.
Yeah, we are lost.
Too much information, sir.
It would help if you explained it in class, sir.
We are lost.
We ain't here to avoid.
Too much.
We ain't here to avoid.
Too much.
Thank you, sir.
I'll come and
Thank
It
you.
would help.
I'm lost.
It would help a lot
Overload.
if you explained.
All right, I'll come and explain the
Extreme.
I think we are good for the night.
Oh, okay, guys. I'll share the link to the uploaded videos. Once they are uploaded, then we can see how it goes from there. Otherwise, class dismissed. Good night and study well, guys.
Thank you, sir.
Thank you, sir.
Thank you very much, sir.
Thank you.
All of you should save nightmares today.
Good night.